Imagine you are very hungry and you have a huge, delicious favorite food kept on the table. You taste the food. Oh, there is no salt added. How would be the taste of it? Have you ever noticed when your mother prepares dosa batter, she adds a pinch of baking soda and she keeps it overnight? The next morning you can see it a little bit puffed or raised up. Why baking soda? Hi, I'm Adil Shah, your science teacher, and in today's class, I will be teaching you the interactions between the metals and non-metals, and I'll also teach about ionic compounds from the chapter Metals and Non-metals. If you carefully look at the periodic table, in the 18th group, you can see some special elements. You know what they are called, right? They are called noble gases. Their valence shells are completely filled with electrons. Because of this, these noble gases do not react with any elements on the periodic table. Therefore, we take the help of noble gases to explain the reactivity of elements as a tendency to attain a completely filled valence shell. Dear students, look here at the electronic configurations of noble gases. And here some of metals. And here of some non-metals. I am going to take a sodium atom. You can see here how many electrons does it have in its outermost shell? 1. If a sodium atom loses the electron from its outermost shell, that is the last shell or M shell, then the next shell, that is the L shell, becomes the outermost shell and it has complete 8 electrons, that is octet. The nucleus of this atom still has 11 protons, but the number of electrons is 10. It means there is a net positive charge that makes this sodium atom a sodium cation, Na+. On the other hand, I have chlorine atom. Can you see how many electrons does it have in its outermost shell? 7. And now it requires one more electron to complete its octet, doesn't it? If sodium and chlorine were to react, the electron lost by sodium could be taken up by chlorine. After receiving an electron from sodium, the chlorine atom gets a unit negative charge because its nucleus has 17 protons and there are 18 electrons in its K, L and M shells. This gives a chloride ion Cl-. So both these elements can have a give and take relation between them. Sodium and chloride ions, being oppositely charged, attract each other and are held by strong electrostatic forces of attraction to exist as sodium chloride. Sodium chloride is commonly called table salt, without which your food would taste bland. It should be noted that sodium chloride does not exist as molecules, but as aggregates of oppositely charged ions. Let us now understand the formation of one more ionic compound, that is magnesium chloride. So, magnesium has 2 electrons in its outermost shell. After it loses these 2, it becomes Mg2+ cation. This combines with 2 anions of chlorine. Each chlorine ion receives 1 electron from magnesium. This gives rise to the formation of magnesium chloride. Like this, the compounds formed by the transfer of electrons from metals to non-metals are known as ionic compounds or electrovalent compounds. These ionic compounds are very large in number. And now let's learn about their properties. Firstly, their physical nature. Go to your kitchen and take some salt in your hand. What do you feel when you touch them? Is it hard or soft? Ionic compounds are solids and are somewhat hard because of the strong force of attraction between the positive and negative ions. These compounds are generally brittle and break into pieces when pressure is applied. What about melting and boiling points? Ionic compounds have very high melting and boiling points because it requires very high amount of heat energy to break the inter-ionic bonds. Now let's talk about their solubility. If you put a spoon of salt into water, it easily dissolves in it. Ionic compounds are soluble in water, but they are insoluble in organic solvents like petrol, kerosene, etc. Now about conduction of electricity. If a solution conducts electricity, then it's only because of the movement of charged particles. A solution of an ionic compound in water contains ions. When electricity is passed through the solution, anions move to the anode and cations move to the cathode. This completes the flow of electricity throughout the circuit. Ionic compounds do not conduct electricity in solid state. This is because it is not possible for the ions to move in solid state because of their rigid structure. But what if you melt the ionic compounds and try? Ionic compounds conduct electricity in their molten state. In their molten state, the electrostatic forces of attraction between the charged particles are overcome due to the heat. Because of this, the ions move freely and conduct electricity. There are many more interesting things to learn about in this chapter, but for today, this much is enough. We will meet you again in our upcoming videos with some more interesting topics. Till then, enjoy learning and stay connected with us by subscribing to Board Plus channel.